All right, so here we've got the sum and difference for the tangent function. So the formula is tangent alpha plus beta equals the tangent of alpha plus the tangent of beta over 1 minus tangent alpha tangent beta. And then the difference is tangent alpha minus beta, which is the tangent of alpha minus the tangent of beta, divided by 1 plus the tangent of alpha tangent beta. Okay, so let's run through the proof here for this, and we'll start with the tangent sum identity. Okay, tangent alpha plus beta is equal to, well, tangent is sine over cosine, so that's sine alpha plus beta divided by cosine alpha plus beta. And now we utilize the sum identities for sine and cosine. So sine alpha cosine beta plus cosine alpha sine beta divided by cosine alpha cosine beta minus sine alpha sine beta. Now what we're going to do is we're going to divide the numerator and the denominator by cosine alpha cosine beta. Okay? So what does that look like? We're going to take the numerator. Okay, I'm going to take the denominator. And I'm going to divide both of them by cosine alpha cosine beta. If I do the same thing to the numerator and the denominator, then I did not change anything. Okay. If I do this, what's going to happen? Well, we're going to have a lot of cancellation going on here. Okay. This is going to be sine alpha cosine beta divided by cosine alpha cosine beta plus, I'm just splitting it up, cosine alpha sine beta divided by cosine alpha cosine beta. And in the denominator I have cosine alpha cosine beta over cosine alpha cosine beta minus sine alpha sine beta over cosine alpha cosine beta. Now, why do this? Well, cosine betas cancel here, cosine alphas cancel here, cosine alpha, cosine alpha, cosine beta, a lot of canceling going on. What does this become? It becomes sine alpha over cosine alpha plus sine beta over cosine beta divided by then 1 minus sine alpha over cosine alpha and then sine beta over, let me write a beta, over cosine beta. Now I wrote that, I separated that out because now what do I know? Sine over cosine is tangent, so I'm going to start doing tangent substitutions. This becomes tangent alpha plus tangent beta divided by 1 minus tangent alpha times tangent beta, which is our desired identity right there, okay? The formula, excuse me, we can do the same thing we've always done for our little trick for tangent alpha minus beta, the difference formula. Rewrite this as a sum of tangent alpha plus negative beta. And what does this equal? It's tangent alpha plus tangent negative beta over 1 minus tangent alpha tangent negative beta. Now tangent is an odd function, so that becomes tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta, and that is our desired result. Okay, so what I want to do is I want to prove, so we're going to establish some identities. Okay, so prove that the tangent of theta plus pi is equal to tangent of theta. Now this makes sense because tangent has a period of pi. So if we add pi to it, we just get right back to it. If you think about the picture of tangent, it looks like this. It's just, it repeats after a length of pi. Okay, so it just repeats. Okay, so to prove this, I'm going to use the identity. So this identity, this is going to be, now one thing that I didn't really, I guess I wasn't super clear on, with identities, you're not moving things from the left to the right side. The goal is to make the left side through algebra look exactly like the right side. Okay, so that's the goal. So you're not adding or subtracting on a side of equation. You're proving that one thing is equivalent to the other thing. So we're trying to make this look like tangent theta. So how do we do that? Well, the tangent identity, this is equal to the tangent of theta plus the tangent of pi over 1 minus the tangent of theta times the tangent of pi. Now the tangent of pi is equal to 0. So that's the tangent of theta plus 0 over 1 minus the tangent of theta times 0. Multiply something by 0, you get 0. So that's tangent theta over 1, which is equal to tangent theta. Boom. So we just made the left side look like the right side. That's the goal when you're establishing identities. Okay. Let's establish another identity. Cosine alpha minus beta over sine alpha sine beta equals cotangent alpha cotangent beta plus 1. Oh my goodness. Okay. So to me, the left side looks more complicated, so I'm going to start with that. So I know the formula here, the difference for cosine is cosine alpha cosine beta plus sine alpha sine beta. Divide that by sine alpha sine beta. What do I get? Well, I get cosine alpha over sine alpha cosine beta over sine beta. I didn't simplify anything yet. I just divided these two pieces. Okay. Now I'm going to divide the second two. And so if I do that, that's sine alpha sine beta over sine alpha sine beta. This is nice. All those cancel and I just get 1. Okay. So what do I get here? Well, the cosine over the sine is the cotangent. So that's the cotangent of alpha. And then the cosine over the sine of beta, that's the cotangent beta multiplied together. And then my plus 1, which is the desired result. Okay. All right. Let's Let's see, how many do we have? Yeah, let's do one more of these. So one more identity. Tangent alpha, theta plus pi over 2 equals negative cotangent theta. Okay? All right. So try it out. Tangent theta plus tangent pi over 2 over 1 minus tangent theta tangent pi over 2. Okay, let's think. What is tangent of pi over 2? Well, if I graph tangent, okay, at 0, I have a vertical asymptote at pi over 2. So this is undefined, okay? So I can't use this identity here. Yikes. All right, so I'm kind of stuck on that one. So can't plug in pi over 2, so got to figure something else out to do. Well, let's try, if I have tangent, let's turn it into sines and cosines. So let's do the sine of theta plus pi over 2 over the cosine of theta plus pi over 2. Okay, so what does this equal? This is the sine of theta times the cosine pi over 2 plus the cosine of theta times the sine of pi over 2 over cosine theta cosine theta cosine pi over 2 minus sine theta sine pi over 2. Now this is going to be 0. This is going to be 1. This is going to be 1. And this is going to be 0. So what do I have left? 0. So I have sine theta times 0 plus cosine theta times 1 over cosine theta times 0 minus sine theta times 1. So what does that equal? That's cosine theta over negative sine theta, which equals negative cotangent theta, which is what I wanted right here. Okay, so once again, to get your identity, make the left side look ultimately like the right side. That's the idea. You're not helping, you're not using the right side to move stuff over on the left or the right. You're trying to manipulate algebraically to make them look the same. All right.